All right. So we're going to do a little bit more long division, but more importantly, synthetic division. That's the quick version for appropriate divisors. In this video, we'll just do dividing by a linear factor for synthetic division. It can be extended to other things. You don't usually see that in textbooks, but it is possible. It's really more of a record-keeping tool. It's an efficient method of long division, so it can extend. So here's our problem. We're going to do x minus 2 divided into 2x to the 4th minus 3x cubed plus 4x squared minus 7x plus 1. Let's just put that down. All right. Good. So this is our problem. And here's how we would set it up for, so that's long division. Now here's synthetic division. And we'll do both of them kind of simultaneously so you can kind of see how it works. So with synthetic division, we write down the coefficients here, and you should include the zero. Well, either method you should include zeros, but you should definitely include zeros for synthetic division. And oops, 2. So that 2 represents the factor x minus 2. We use the negative of that. We'll see in a little bit the role of that 2, why we'd want to do that, but that's how this works. So, first step. Okay, so over on the long division side, what would we do? X minus 2, we need to get rid of this 2x to the 4th, right? And so we write down 2x squared. And so we multiply that, 2x cubed. We multiply that by the thing over here, and then we do minus 4x cubed, and we're subtracting all that, and so we get 0, and then we get, let's see, that becomes a plus, so it's plus 4x cubed, and minus 3 minus x cubed, right? And then we bring down the rest. Well, we can just bring down the next term there. All right, what happens over here? We bring down the 2, and then 2 times 2 is 4. We add that up, and we get 1, right? So, oh, right. Sorry, that should have been a plus 1. You're probably screaming into the ether. All right, so this 2, right, is basically this 2. And this 4 is basically this 4. And this 1 is that 1, right? So if you think about it, in long division, you're canceling that leading term. Well, you don't actually have to do that, right? Assuming you've done it right, you get the right number to do that, you don't actually have to write it down and cancel because it cancels. You know it's 0, right? You don't need to compute when you know it's going to be 0. So get rid of that, right? And instead what happens, that factor that you got, that 2, you multiply it by the, this minus 2 here, and then that gives you the minus 4 here, and then you're adding them. Of course, now we're negating it because we're subtracting. Hence, if we had a plus 2 instead of a minus 2, we've already done the subtraction. And so that becomes just a plus 4 and you add, right? So that's why we don't need to do any kind of sign changes, because we already did it with the 2, because that's the only part that actually matters. Excellent. And so what comes next? Well, what comes next is now in long division, we're trying to get rid of that x cubed in front there, so we just add in this x squared term, and we do that computation, x cubed minus 2x squared. We subtract, and what do we get? We get that 0, of course, plus 2x squared, 6x squared. What do we do over on this side? We take the 2, multiply by the 1, we get 2, add 6. Pretty sweet, huh? It's still the same content, right? So red is, so that plus 1 there, this 1, it's the same 1, right? So that was redundancy. And then we multiply it by the 2 to get to the 2, and that's, oops, what did I do before blue? Blue, but with that minus sign coming in, right? So, and then the green, that's 6. We just keep going, right? 12, 5, 10, 11. Okay, that's pretty simple, right? Let's keep going over here. 6x squared minus 7x. Oy vey. So we need to get rid of 6x. So, at this point, I no longer can recall if I'm doing a different sign or not. I think I do this. 6x squared. It's really awkward to switch between these two methods. And 12x. And then you subtract 0, 5x. And now we do one more. I guess that's a plus 1. 5x squared minus 10x, do minus, oops, not squared. Anyway, this, and then negative 10, 11, so remainder. Right? And so what do we have? We have so this thing says basically, so 2x, so there's 4 terms here. So that's a third degree polynomial plus x plus 6x plus 5. Everything was positive. And then, so all of that times this x minus 2 plus 11 equals that original polynomial. And that's what that says too on top. All right? So that's long division on the left, synthetic division on the right. Hopefully it's pretty clear that they're the same, and it's just really deleting a lot of redundancy in that long division. It's useful to see how the long division works. Synthetic division will work for all long division, but I have to explain a little bit more to get to the next ones and what happens. However, there is one caveat. Leading coefficient of divisor must be 1. Oops. Must be plus 1, right? Because if you look at it, x minus 2, that coefficient of x, which is 1, doesn't really appear in these computations. We're assuming that that's 1. If it's not, then you have to kind of keep that factored in, because things are getting a little bit messier. Particularly, like it just that the next ones, as you don't get the next coefficient thing, so you'd have to do a little bit more something. And by that point, you're just going to get confused. But fortunately, you can always just get rid of it, right? So like, let's say that you wanted to divide by, let's say, 4x squared plus 2 divided by 2x minus 1, you can factor out that too. This is the same thing as 2x squared plus 1 divided by 2x minus 1 half. And now we could do that division pretty easily. So you could do 1 half here. Fractions are fine. Any number, it's fine. Complex numbers, it's fine. Whatever you want to do. We add in that 0 for missing the 0x, and bring that down. 1 half, 1 half, 1 half, 3 halves, right? And so this is saying that basically x minus 1 half times x plus 1 half plus 3 halves is equal to x squared plus 1. Right? And you could multiply by 2, I guess, to change something or other. And does that actually work? It seems to almost work. X squared minus x plus x is, those things cancel. And then multiply them together, it's minus 1/4. There we go. This is 5/4. See, fractions. And then minus 1/4 and give plus 1. There we go. So yes, that works. Anyway. Oh, and I guess when we're writing it like this, it's going to be, we can write it as, we haven't really, but it's x plus 1 half plus 5/4 divided by x minus 1 half. All right, that's what this also says. All right, so that's somewhat synthetic division. I guess one thing to note is, let's see if I can do this. So let me just plot this thing in here, 2x to the 4th minus 3x cubed plus 4x squared minus 7x plus 1. All right, so that's my function. And if I just do 2 here, I get 11. Was 11 special? Oh, yes. What was 11? 11 is this. So this is p of x, right? And so what is p of 2? P of 2 is equal to 2 minus 2 times this whatever plus 11. What's 2 minus 2? That's 0. 0 times whatever is 0. Equals 11. So the remainder, when you divide by a linear factor, is the value of the polynomial. And now think about it. If you were to compute the polynomial directly, so you plug in 2 in here, and you get 2 cubed, that's 8 times 2 is 16. 16 plus 2 squared, 4, so that's 20. Plus 6 times 2, oh, sorry, I'm looking at the wrong one. That was the reduced form. 2 into x to the 4th. Okay, that's 16 times 2 is 32. 32 minus 3 times 2 cubed. So cubed is 2 cubed is 8, 3, 24. So minus 20, 32 minus 24 is 8. So I'm at 8 now. 8 plus 4 times 2 squared, that's 4, so 16. What was I? 8, 16, I don't know, 24. Minus 7 times 2 is 14, so that's 10 plus 1 is 11. All right? Just think about all that computation that just went into all that. And then think about the synthetic division. Not only does the synthetic division give you that 11 pretty simply, very efficiently, it actually also gives you a factored form if for some reason you need it. Now, why might you need it? Well, what happens if that remainder was 0? You've got a factor, and now you've just reduced the polynomial. So you've got a factor and then times whatever. So 0 is really nice there. And so, yeah, synthetic division is awesome. Synthetic division is awesome. Okay, let's try that same polynomial with another number. Okay, so we'll try evaluating at x equals 3. So notice that if I'm thinking about evaluating the polynomial at the value, that's actually the value I'm sticking in. So that's kind of nice too. So the coefficients were 2, minus 3, 4, minus 7, and 1. There's nothing special about this polynomial. I just happen to have it. I plugged it in. Just explore it. So bring down the 2. 3 times 2 is 6. 3, 9, 13. What is that? 39, 32, 96, 97. All right, and so we've essentially factored it as x minus 3 times, well, not factored, this is a remainder. But so it was a 4th degree polynomial, so the reduced form is, if you divide by one factor, one linear factor, you get one less degree. So 2x cubed plus 3x squared plus 13x plus 32 plus 97. And so that's our p of x, and p of 3 is equal to 97. Now think about doing that with the polynomial itself. By the way, just boom, 97. Well, that was easy. So 3 to the 4th, 81 times 2, 162, ouch, minus 3 times 20, so minus 81, oof, plus, and so forth, right? Ouch, don't do that. But pretty easy. I mean, it's going to get large. As you get farther and higher numbers, the higher powers make a bigger difference, and things multiply out of control. Let's try a negative one. So let's say x equals, just say minus 1. 2 minus 3, 4 minus 7, 1. And we just do that. 2 minus 2 minus 5, 5, 9, minus 9, minus 16, plus 16, 17. Right? And so this is then saying that x plus 1 times, so these are all different forms of the polynomial. Oops. 2x cubed. Notice that I always have that 2x cubed part in all of these things because that thing just comes down for the ride, right? It's fine. Again, that's because the factor I'm dividing by has a coefficient of 1 in front of the x, so it's not going to change that leading term. Anyway, minus 5x squared plus 9x minus 16 plus 17. So p of minus 1 is just going to be 17. And we can check to see if I made any mistakes by going back to our little table. And what was I doing? Minus 1. 17. Easy peasy. Right? So there you go. How to evaluate a polynomial Now to write it down in a factored form using that evaluation. It's, 2-for-1 deal. You want to compute the remainder, the polynomial value, and you get a nice little different version to look at. And it actually has some nice features that we'll potentially talk about some other time. But that's synthetic division with a linear factor. That's how it goes. Very simple to set up. You write down the coefficients of the polynomial you want to divide into on the top row. Add in zeros if there's missing factors. Okay, that's very important. And then on the left, you write the number you want to evaluate the polynomial at, or the minus of, if you have the factor like x minus 5, you write down plus 5. And then drop down the first coefficient, multiply by that the divisor number times that, put it in the next column, add, multiply, add, multiply, add, multiply. So you're done. Easy peasy.